Mathematics, Advanced Subsidiary Level, Paper 2, 2022, Part 2. Mathematics, Advanced Subsidiary Level, Paper 2, 2022, Part 2. Let's look at question number 3. The diagram shows part of a curve whose equation is this, and this is a trig equation. Okay, that makes it a little bit more difficult, but remember in further integration, you did a trigonometric part, how to integrate trig functions. Okay, where x is measured in radians, it is very important. If you see something like this, underline. The curve crossed the x-axis at the point A, and the shaded region is bounded by the curve and the lines x equals 0, that is that, and y equals 0, which is making sense. Can you see that? Okay. Okay. So, find the exact coordinate of A. Now, remember this, you did it in linear programming, you can do it in any graph. Where you want to see where it cuts the x-axis. So you can even say, when it, I'll just get my pen correct. When it cuts the x-axis, you make y is equal to 0. Okay, and that's what I'm going to do. So 0 equals 2 sin square x plus 7 sin x plus 3. And again, it's a trinomial. Can you see how important? It's a second question in this paper. We are at question 3 that we're going to factorize. Okay, so you have to be able to do that. So I'm going to start and I'm going to say, okay, it's 3 and it's going to be 1 and 3, and it's going to be 2 and 1 because I have to add the overcross products because there's a positive. So it's 6 plus 1, which is 7. The signs are the same. And then rather just take, you don't have to go for k, just take the middle term. The middle term will be sin x, sin x. In the beginning, you can do it in terms of a k or a variable. But later on, if you developed in the year of mathematics, I think it's easy to do it straightforward. Okay, so I'm going to have sin x plus 3, and I'm going to have 2 sin x plus 1. Okay, now I'm going to put both equal to 0. So if I'm going to have sin x equals negative 3, I just skip that one step, the space is not enough. Or I have 2 sin x equals negative 1. Okay, so I'm going to have sin x is negative 3. Now, can you see, because this is just x, now remember your sin graph. You can even press it on the calculator. I just want to see where is my calculator. But let me first explain it to you by looking on the graph. But if you have a graph, the sin graph is like this. The maximum, the normal sin, is just between 1 and negative 1. But if you look at that, you will see that that is going to be above. So even if you press that on the calculator, it's not going to give you an answer. So this is not applicable. So you're going to have sin x is equal to negative a half. Okay. But now, I want to find, they say find the exact, I want to find the value of x. Now, it's in radians. Now, in the textbook, you can see, and I'm going to tell you, I didn't tell you where to find it. So, page 168 or 169. I can just quickly check if it's 168 or 169. Okay, so if it's 168, I'm just looking for that 90 degrees. So it's on page 168. I want to show you that although you do part theme 2, you use a lot of the knowledge of part 1, and this is what I'm using. So can you remember if you have that graph, the 90, or the 60, the 30, but can you remember that the 30 was pi over 6? No, and I think I'm going to redo this. Okay, I'm just going to redo it. I think I'm going to, you can put it in that space, but for myself, it was an equilateral triangle. Can you remember? And just for the video, I want to do it more clear. So if this was 60, can you remember? But it was also pi over 3. And this was 30, you will see it there on page 168. Okay, and this was pi over 6. And because it was an equilateral, can you remember? This was 2, but then it was cut into this side because it's continuing there, okay? And then Pythagoras 2 squared minus 1 squared, and that was the square root of 3. Okay, now, if you're going to say, where is sin negative? Okay, so let's just quickly look here at the Bredon curve in the lines, find the coordinates. So I'm going to say that in this, where sin is negative, now think of your cast diagram. Okay, so sin is negative going to be in this quadrant. Okay, let's just go there. It's going to be in this quadrant, and it's going to be in this quadrant. Okay, but now if it's a half, so the negative show you it's in these two quadrants. Okay, I just want to see now, due to the fact that you can see it's just going to be in this, it's going to be the first value. Do you see where it cuts there? Where it's going to be negative, and it's in this quadrant. So if it's a half, now remember sin, don't forget, it's opposite over hypotenuse, okay? So if I'm say a half, where this is the opposite, this is, can you see? This is opposite, and this is hypotenuse if I work from this angle. So therefore, I can see that the value is going to be pi over 6, but it's not the value of x. It's going to be that value. That value is going to be pi over 6. But remember, we are interested in, I want to use another color, we are interested in this. So we are interested in, I can write it just here, we are interested in, now I will first write it here, so it will be, to get x, it's going to be pi, because that's pi, plus pi over 6. And that is going, remember, this is 1 or 6 over 6 pi plus pi over 6. And that's going to be 7 pi over 6. So the value of x, so therefore x is 7 pi over 6. Now I want in this question, I want to first take you to the report with A. As soon as I did, because I said a lot of things in this question, I refer to a lot of things, and I just want you to show you what is the report telling us. Okay, so let's go there to the report, and let's see what the report is saying to us. Question number 3, I see it there. Okay. Okay, this question also tests the candidate's knowledge on, oh no, I'm sorry. Seems to me I'm in ordinary. Okay, here is now. Okay, here I am. This question was poorly answered because you had to think of so many things in that first one. It was often seen that candidates lacked the basic knowledge that where it cuts the y equals 0 for the x-intercept, and wrongly made it x. No, when it cuts the y-axis, x is 0. When it cuts the x-axis, y is 0. Once again, many candidates wrongly use the substitution of sin x equal x instead of sin x equals k or any other variable. That's mean if you put a k, but you can factorize directly. This resulted in a commonly wrong answer, x equals negative, instead of sin x equals negative 4 half. Some of the candidates who correctly reaches this state failed to realize that they only needed to work in the second quadrant, as A in the first solution where x equals is x bigger than very common wrong. Okay, keep that first in mind. I'll show you, here it comes in the third. Solutions with negative pi over 6 where the candidates wrongly used in their calculators. Another common wrong answer seen was pi over 6. No, it was negative sin, resulting from the correct use of sin a half. The mistake so they just work on the calculator almost. The mistakes these candidates made was that they did not, and here it's come, realize that they actually needed to work in the third quadrant. Did I show you? Once again, this shows the lack of basic knowledge of the ordinary level syllabus. So you don't work in the second, you must work in the third. And if I go back to that question, I'm just going to again show you that. So basically, I was just showing it is pi over 6, but that part is pi over 6. And you are instead of this, because if you look at the graph, it's the first where it's going to cut there. So it's going to be pi plus the pi over 6, which will give you the 7 pi over 6. Okay, now let's go to the next question. So I must say, it's actually, if you didn't have this value, it would have influenced you quite a lot in B, really. I think they had to say show that, because now you're going to lose that 5 marks then. Okay, but you can still get for method. So remember that. Maybe not for the substitution, but definitely I'll show you now how you could have still gained marks even if you didn't come to the 7 pi over 6. Okay. Now, as soon as they say, find the exact gradient of the curve. Now, people, when you see these words, gradient of a curve, you think of differentiation. You have to look for that keywords. Okay, so basically what I'm going to do is I'm going to factorize this now. I'm going to say, if I factorize this, if I want to find dy over dx, I'm going to factorize all three because it's just plus. So it's 2 sin squared x. Okay, and I factorize this term. And I say sin x. And I factorize this term. Okay. So basically, what I'm going to do now, I'm just going to quickly start. Now, this factorization, remember it's differentiation. Now, if I'm going to factorize this, I'm going to use the chain rule. Now, if you do it here in between, you might be, so I think if you rather do it in this space, if you're going to say, okay, I want to take another color, that it don't become too messy, okay. I see I have a page here for you, and that's page 488. Okay. So this is going to be y equals 2 sin squared x. So y is equal to 2 u. Okay, let's rather do it first like this. You can always do it on the extra page and then just write it in. But I can say that u is equal to sin x. And I can say that y is equal to 2u squared. Do you see? So it's the chain rule. Remember, I'm using the chain rule. So now I'm going to say du over dx. I'm busy working with that one. And now I can take you to the, I must now take you first to the, remember it's differentiation. Say to yourself, differentiation. I can take you to this formula sheet. I want to show you. So look for differentiation. Oh, there's differentiation. Let's just make it bigger. So if I'm going to differentiate, I'm going to differentiate sin x. What is the differentiation there? Differentiation of sin x, I want to underline, sin x is going to be cos x. Okay, so go back. Did you see? I used my sheet. So I'm going back, previous. So as I said, you could have do that chain on the other page if you feel it's going to be too, I don't want to write on this side because you don't have that. Okay. So this is going to be, what did we say? Cos x. Okay, so let's just say cos x. Okay, now I'm going to say dy over dx, and that's going to be, no, sorry, my focus is in the incorrect page. Okay, so this was this, now dy over du, I'm here. So dy over du, and 2 times 2 is going to be 4u. And now if I multiply this 2, and I'm just going to do it here, I'm going to say dy over dx, it's going to be 4u, okay, let's just get that u, cos x. So it's 4, and what is u? Don't forget, u is sin x. So it's 4 sin x cos x. Okay, and I actually didn't want to write in this space. So now what I will do is I will. So if I can give you advice, rather write this on the extra page. Okay, so now as soon as I do this, then I can just write the answer here now. Remember what I said, I use the chain rule. So it's 4 sin x cos x. Okay, I want to say there's another example. You can look on page 489. Try now 18. Will also help you. Okay. Now this one, if we go to sin, I'm not going to go to the page now, but I'm just going to be sin becomes cos. So it's going to be, we did already that. So it's 7, we did in the previous, that's going to also be cos x. And what happened to a constant? Just falling away. Okay, so now I have my expression. So even if you were not having now that 7 pi over 6, you could have still differentiated correctly. And we will now see how many marks that would have helped you with. Okay, now I'm just going to substitute. It's like I'm substituting now that f 7 over 6 pi. And don't forget that it's in radians. So I'm just going to say 4 sin 7 over 6 pi cos 7 over 6 pi plus 7 cos 7 over 6 pi. Okay, now you can actually find this without a calculator, because you just have to work with this triangle here, and just the 7 over 6 will just be telling you, it's almost, can I rather say it like this, you can work with this 2 to help you. Okay, so let's do it. We want to do it with, so 4 sin, now sin is what in that quadrant? Negative, so that's why it's negative. But you can, so the negative is saying I'm in this quadrant. But now I can just work with pi over 6. What is pi over 6? That is going to be opposite over adjacent, is going to be a half. Okay. Now cos. Now what is cos in this quadrant? Cos is positive there. So what is cos? It's also negative. But now, what is cos if I stand there? It's adjacent over hypotenuse. Do you see? So it's square root 3 over 2. Okay, plus the 7. And again, it's cos. So it, but again, what is, so it's again negative. It's the same. Square root 3 over 2. And I'm going to simplify it on this exact road. Okay. So what will I find here? Now, remember, this is 4 over 1. So 4 is on top. Are you with me? A negative times a negative is a positive. Okay. That is square root 3. And that is over 4. Do you see that? Minus 7 over 2. And that is also square root 3. So if I really look at this, I will say, because that 4's cancel, do you see? So it's going to be square root 3 minus Okay, what is this is going to be? It's 3.5. 3.5 square root 3. Did you see? So it's 1 minus 3.5. So what is it going to be? It's negative 2.5 square root 3. Or if you want, you can say negative 5 over 2 square root 3. So I was able to work this, find the exact. So it means you could not use a calculator. They wanted you to work exact gradient of the curve at A. So after I differentiate, I substitute the x value there of A, which I got in A, and then I got the exact value. So they wanted me to do it like this. Let's just go to the report again and see what they are telling me there. They say it's poorly answered. There was no reason to use double angles in this question. Many candidates use double angles and wrongly through that they differentiated already. Thought that they differentiated already. No, it's not. It's differentiation that you did here. They clearly did not realize that the use of double angles is just an alternative way to write two sin, not a way to differentiate. Okay. So, candidates could easily have used the chain rule, that's the one I used, to differentiate. Okay, these candidates would first differentiate the bracket, okay, and getting that, and then differentiate the sin cos, resulting in the correct answer of that. Alternatively, the product rule could very successfully be applied. These candidates just wrote this and then used the product rule to differentiate this. Okay, doesn't matter. You can even try on the other method. So many candidates only succeed to differentiate 7 sins to 7 cos in this question. Okay, so because that was the easy part. It should be noted that substitution of the angles must be clearly shown. The answer was ask exact. So candidates were not allowed to convert their answers to decimal, not allowed to use the calculator. And maybe I just want to show you, I don't know if I showed you the previous one already up to there. So there was the 7 over 6. And let's just look. So basically, if you use the chain rule, you got that. So you got that marks. Do you see how many marks are you there? Okay, then you got that answer in exact. So without substitution, I think you could have got 3 marks. Did you see? If you were not having the answer of A, 7 over 6. Say you didn't succeed in A, but you could still get 3 out of 5. So very, very important that you look and that you at least just do some of the methods to just score marks in the question. And there is the final exact answer. And there I showed you also the other method of doing it. Let's continue with number C. By expressing 2 sin square x in terms of cos 2x. They actually help you. They first say, use trigonometry, first express it like this, and then you find the area of the shaded region. So it's almost, if you read the question, sorry, I just want to move it down, then you think here trigonometry, and area of a region, just like the gradient of a curve is differentiation. Area of underneath a curve is integration. So basically, I'm going to integrate now that formula to sin square x plus 7 sin x plus 3 dx. That's what I'm going to do. But now remember, I must get rid of this. Okay, I must do something else. I must first adjust that before I can integrate. Now, I did it for you on page 5 to 7. If you look, there's a small block underneath, page 5 to 7. But I want to show you, I want to derive it again for you. Okay, so let's first go to the formula, because they said cos 2x, sin 2x. Let's go to trigonometry, the formula sheet. Okay. So if I look here, let's just make it smaller. That's differentiation. Okay, here is trigonometry. So on the formula sheet, I'm at trigonometry. Now, if I say there's a cos 2x, remember it's now not a, it's just going to be x. And it's that what I did for you on that 527. So let's just go and write it down. I'm taking that out of trigonometry. Okay, so let's just go back. Okay. Okay, so basically, it's just going to say on the formula sheet of trigonometry, it's going to be, and I'm just going to use another color, sorry. It's going to be cos, and remember, work in x. 2x was equal to 1 minus 2 sin squared x. So I'm working with this. Now, I want to make that the subject. So take the 2 sin squared x over and say 1 minus cos 2x. Okay, are you with me? And now I'm just going to get this alone. So I'm going to say sin squared x equals, I divide by 2 basically, put that bracket. So I'm getting a half 1 minus cos squared x. Okay, so that is what I'm going to do. So I'm going to now use the trigonometry. And I'm going to, and in the place of this, I'm going to put this. Now, don't forget the 2 was separate. So it's going to be a half, and then it's going to be 1. I can actually multiply it in, but it's all right. 1 minus cos 2x plus 7 sin x plus 3 and dx. And then 2 times a half is just going to be 1. So I'm sitting with 1 minus cos. I didn't integrate yet. Do you see that? I'm just getting it ready for integration. And I even simplify further. And I'm doing, you don't have to put all the steps. I'm just for the video. So it's 4 minus cos 2x plus 7 sin x. dx. Okay, now I'm ready to go and I'm going to integrate. Okay, now can I just, because there is going to be my next hiccup. Now remember, the formula sheet will just show you how to go from cos to sin. But it's very important, and I put it nicely for you in the summaries. So if you're going to look at the summary, remember I'm busy of integration. You will see and really memorize that summaries in my textbook. I'm going to quickly give you that summary, because in the formula sheet you will not see the extra. But if you look there on page 54, it's on page 545, you will see the extra. So they will tell you, okay, that cos will become sin. Okay, but in my summary sheet, I made it easier for you. I wrote it for you. If you have cos and you have ax plus b dx, and you integrate it, differentiate, it's not 1 over. Okay, but then it's 1 over a sin, and then the bracket as it is, ax plus b plus c. Okay, so in the formula sheet, you will not see the extra, but in my book, you will see the little bit extra step on page 545. Okay, so let's start and do that integration. So it's going to be 4x. Now here comes. Okay, so minus, and now it's just going to be a half, because that is 2, that's a. So it's a half sin 2x plus 7. And now what is sin? Look on the formula sheet. That's easy. It's minus cos x. Okay. And now, I don't forget that the two boundaries is now 7 over 6 pi. Okay. And that, let me just do that correct. 7 over 6 pi and 0. Okay. And now I can do the substitution. So now I will just go, okay, So it's 4 and it's 7 over 6 pi minus a half. And sin, don't forget sin, and don't forget 2, and only there you say 7 over 6 pi minus 7 cos 7 over 6 pi minus, and don't forget to also substitute the 0. Okay, so then it's going to be 40 minus a half sin 20 minus 7 cos 0. Okay. And now, if you want to simplify this a little bit further, you can say this is going to be 14, because it's going 2 can go in 2, 2 can go in 3, so it's 14 over 3 pi minus a half sin 14 over 6 pi minus 7 cos 7 over 6 pi minus, now this becomes 0, this becomes 0, but cos 0 is 1, so that becomes negative 7, but don't forget it is in brackets, so it's actually going to become plus 0. Now, I press it on the calculator, and then sometimes you, especially the young people, you're very good on calculators, but then I make a mistake. So I decided, just to make sure I'm not making a mistake, I'm just going to write all the calculator displays out. Just remember, your calculator must be on radians. Put it on radians. So if I press this 14 over 3, I was getting 14.66076572. You don't have to do it. This is now very long. If you were saying half, multiply sin, 14 divided 6 multiplied pi, I get 0.4330127. Oh, sorry, I don't want to write so bad. 433012701 plus, okay, this one becomes a plus, then it was 6.062177.826, and then this negative times this negative was plus 7. Don't approximate in between if you do it, and then write down your full calculator's display. So I was getting 28993085, I think. Doesn't matter, that will not be influenced. But my final answer was 27.3. Okay, let's go to the examination report. Okay, so basically, this is number C. There they showed you, do you see? And then they showed you there, and then they showed you how you put in all that steps. You see there, and then they said 27.3. I didn't read for you what they said. Okay, let's see. Extremely poorly answered. I want to make it a bit bigger. A very common misconception was to just change 2 sin to 1 minus cos 2x and only integrate these two terms instead of the full given expression. The question was structured in this way to assist the candidates to realize that they needed to change the given expression to a form that they can integrate first before they attempt to integrate. So first you use trigonometry. It was shocked to see how many candidates did not succeed to make 2 sin the subject of the formula from the given formula in the formula sheet. Once again, it was seen quite often that the variables were changed from x to a. No, keep your question is the master. Okay, that's x. Candidates should be taught that they need to convert the variable on the formula sheet to the given variable immediately. Okay, and then we can just see what they still wrote there for us. It was also seen once more that candidates were under the impression that if they do the conversion to double angles that they integrated already. Now, you used trigonometry, you didn't integrate. They did not realize that by using double angles, they only wrote this in an alternative form, which still need to be integrated. It should be emphasized that the substitution of both boundaries must be seen. It was seen often that candidates wrongly presume that the substitution of 0 results in 0. No. They're going to catch you out. Work it out, make sure that there's not a number involved. Okay, and that was then the final. A lot of trigonometry, but as I said, just make sure when you do what. If it's not just in trigonometry, when are they asking differentiation? When are they asking integration? I think what I was thinking is it would be good if you take all the summaries and you make for yourself a nice summaries by saying, when it comes to trigonometry, just on one sheet, say, okay, this is the trigonometry, the double angles, the angles. This is how I integrate, differentiate it. This is how I integrate. Put it on one sheet so that as soon as you come to a question like this, it's just reflected in your mind and you can use the correct formulas. As your final exams approach, I want to highlight the importance of the y equals mx+c mathematics textbooks. If you don't have them yet, you can find them at the following bookshops. These textbooks will be your reliable study companions, guiding you towards mathematical success. For educators aiming for exceptional maths exam results, start using the y equals mx+c mathematics textbooks used by leading schools in your classroom. They are part of the NEET catalogue and can be easily obtained within your ministry's textbook budget. Make sure to communicate your request to your region's procurement department to empower your learners with the best educational resources. Furthermore, schools have the option to place direct orders with us, and we offer bulk order discounts. Reach out to us via email at the address below. Best of luck in your maths journey.